All right, guys. Hey, welcome back to another lesson. Today's topic, solving systems of linear equations with matrices. Okay? You solve systems using substitution, elimination, and graphing. Okay? Today we're going to see how does a matrix play a role in this? How can we use it? And to be honest with you, it's probably my preferred way. It really is, just by preference. I like it a lot. But that's what we're going to look at in terms of this whole topic, is how do matrices fit into this? Because we already done this before in the past, okay? By the way, I'm going to do this in two parts, a two-part video. This first part is just me kind of explaining what this is. The second part will be me solving these guys, okay? So here we go. This is a general form of a system, okay? And we've seen this before in the past. This is just introducing some of that matrix stuff that we've talked about. So here's my first equation, okay, and everything's x's in this case. You could put x, y, z, those different variables. As you know, these little subscripts here indicate what element in the matrix you're looking at. So like if I just put brackets around this is just one giant matrix. So we're in row 1, column 1, row 2, column 1, okay, and so forth. Just a review of what constants and coefficients are. Remember, constants are just the values that are by itself, doesn't have a variable attached to it. And that's what's over here in this column, okay? Those are the constants. The coefficients are what in front, they're in front, see, I can't talk, in front of the variables here. So the A11, A12, okay? Those are the coefficients, sorry. Okay? So like I said, we've seen this before, we're just writing it with some matrix stuff with it. Okay? Two different types of systems. We have homogeneous, which is all the constants on this side are zeros. And then non-homogeneous, that system is when the column over here, that the constants are not zeros for that guy. Okay? So, in other words, these are just adjectives. That's all they are. Okay? They're just describing what type of system you have. Okay? Now, let's go into another term. There's a lot of vocab here, so I do apologize ahead of time. But I just want to make sure you guys, if you ever hear some of this terminology in college, that you guys are good with it, okay? That you have heard of it. An augmented matrix, the solution to a system does not depend on what symbols are used as variables, which is pretty true. Think about it. Oops. I was already ahead of the game. Sorry. So, for instance, like if I had this system right here. Okay, let's say we're trying to solve that system. Are we really concerned about the variables, really? No, we're more concerned about the coefficients in front. That's what we're looking at. If I was to solve this by elimination, I'd multiply this by 2, right? And then I can cancel the x's by adding them. So I was more concerned about the numbers than if this was an x or a y. I didn't care about it until the very end of the problem. So what an augmented matrix does is it takes these guys, just the coefficients, out of the problem. And that's all we're going to be messing with. It's just those values. At the end, okay, don't get me wrong, at the end, we're going to actually interpret it. Like, okay, what does this number represent again? Oh, the x. What's this number represent? Oh, the y value. Okay, so we'll get to that. But for right now, we're not concerned with it. We just want the numbers. We're just going to crunch some numbers. Okay? So that's what this is talking about here. When you hear the word augmented matrix, you're getting rid of x, y, z, or whatever variables you're using. You're just looking at the numbers. Okay? So what does one look like? So let's say this is my system that I want to go ahead and solve. I want to figure out what x and y are. To do that, I'm going to solve it by using a matrix. What I'm going to do is I'm going to take these coefficients and I'm going to bring them down to here. Okay, so you see how the 2 and 3 gets put here, the 5 and the 4 here. I did color code it, maybe it's a little bit easier. Okay, so the first column represents all the x values in my system. The second column represents all my y values in the system. So far, so good. Okay. And then the word augmented literally is just you're tacking on, you're adding on to the matrix. So the reason why we call it augmented is this part right here. This vertical line separates the coefficients from the constants. So on this side, we put the constants here. Okay? So do you see just how we literally just took the numbers, x's and y's, goodbye. We're leaving them behind. We're not going to use them right now. We're just going to focus on the numbers. And then we're going to use this guy to solve for x and y. Okay? So far, it looks weird, isn't it? But it'll get better. Okay. Now, how can we solve now from there? Well, if you go back to what we did here, ignore that there's x's and y's. When we were trying to solve this, we were allowed to what? Multiply one of the equations by a number and then add it to the other equation, right? We were allowed to do that. Or, we could have multiplied this by a value and this by a value and then add them together, right? We didn't multiply by 0, though. Let's be clear on that. 0 was not an option because if you multiply anything by 0, you get 0, and that's not helping you solve anything. So we had to multiply by something that wasn't 0, non-zero, okay? And we're allowed to add these guys together. Guess what? We're doing the same thing. The row operations you're allowed to use would be multiply a row by a non-zero constant, add a non-zero multiple of one row to another row. Okay, we can do that. The only new rule that you don't know of is this guy. You're allowed to switch the rows. Okay, so for instance, let me go back to that previous slide. I could take this 2, 5, and 10, and I could bring it here and bring up the 3, 4, and 24 and bring it up to here. I'm allowed to switch them. You might want to think, okay, why is that useful? And that'll come in part 2 of the video when we actually solve this. Okay, so those are the row operations that we're going to be using. Okay, once again, might seem weird. We didn't get to the actual problem solving aspect. We're getting there. Okay. All right, there are 2 types of elimination. There's Gaussian elimination, okay, and what that looks like, and this is the part. When we're solving this matrix, okay, we're going to see it in 2 forms, this form or this form, depending on how far we go in terms of solving. If we stop here, like you see these little asterisks here, okay, that's just numbers, any number whatsoever. But if it generally looks like this, then we're talking about Gaussian elimination. Okay, so that's one type of elimination. That's what it looks like. That's our goal. Our goal is for our matrix to look like this. Down here we have what's called Gauss-Jordan elimination, and that's when we have 1s on the diagonal but 0s everywhere else. So if we solve a matrix and this is what it looks like in the end, then we use Gauss-Jordan to do that. Okay. Once again, I just want you to know that these terms exist and what they are and how they relate to the actual problem itself, okay? An actual college class, you would go a lot further with this, but for right now, we're just covering very briefly just some of the basics here, okay? Now, one final thing, this word right here, echelon form, okay? Anytime you hear that, echelon form is pretty much you're putting 1s in critical parts of this matrix, okay? So this is row echelon form, where we have 0s here in this bottom corner, 1s across the diagonal here. This one down here is reduced row echelon form, another adjective describing that this is what it looks like. Okay, we have 0s once again at the bottom. Okay, if you ever have just a full row of 0s, that could happen. If you were solving a matrix and you had 0, 0, 0, you want to make sure that's in the bottom of your matrix. Okay, and once again, that'll make more sense when we start solving some of these. A lot of adjectives, a lot of ways of describing. I'm just trying to make you aware of what these things are for right now. Okay? Alrighty. So, that is it for part 1. Like I said, just a bunch of vocab for right now. So, my notes, I do have uploaded, so you can kind of see what they are. Row echelon form, I described it, but I do have a PowerPoint slide as describing what I just said there. So, feel free to look at that. Other than that, hey, I think I'll see you in part 2. How about that? See you in the next lesson.